topographic form, or shape of the surface of the Earth, as they all combine to or put into effect, the types of forest composition that we see around different places across the United States. For this exercise, we're going to use Mount Monadnock, also known as Grand Monadnock, as our case study area. And as you saw from our quick warp-in flight there, just over the tip of the mountain peak here, you can see the capital of New Hampshire, Concord, and that is indicative of the kind of forest composition we'll be looking at. So, this is in northern New England. It's one of the most northern states. It's just outside of Maine and just south of southern Canada. So we're going to be looking at a northern hardwoods forest composition when we're talking about places like the low-lying country in the valleys. So, on a typical trip to Mount Monadnock from, well, about a third of the United States population lives within a half-day drive of this place, so you can imagine it's going to be pretty busy at times. And we'll see how those things kind of interact. But as you're driving in, you run into a lot of typical northern hardwood species. So some of the hardier oaks, things like sugar maple, silver maple, a lot of species that are used also for fuel wood. So just outside of the kind of example study area here, we have a town forest, which is used for clean water for the nearby sort of towns and villages in New England here, and also for fuel wood to heat their homes during the very cold northern New England winters. So this northern hardwoods regime is kind of a patchwork these days. It's been logged over several times in the few hundred years since Western European settlers have arrived. And since then, it's kind of come back in waves, and parts of northern New England are actually afforesting. Pretty cool stuff. But as you drive up the slope and you start to get into sort of the foothills around Mount Monadnock along this access road that will take us to the visitor center, the parking lot, and the trailhead, we see that the northern hardwood composition is going to go from sort of a closed canopy, mixed-aged set of stands that have been historically logged to something that's a little bit more, hey, there's your intrepid professor, something that's a little bit more open canopy, same species, but having a little bit harder time as slope increases, as in this photo, and as you can see kind of in the 3D version here. It's harder for these trees to maintain that closed canopy, to compete with forest floor and sort of middle story shrubs and opportunistic species. Heading on to the trailhead and sort of the first stops along the trail, we'll run into a pretty different situation. So notice that down in the valley, we still mostly have some green, some seasonal senescence into wintertime footing for those hardwoods. But heading up just a couple of hundred feet from that valley floor position, we see that autumn has advanced forward effectively a couple of weeks already by this point. And so continuing up the trail, we'll see a further struggle for those hardwood species to try to outcompete evergreen species like red spruce. So what that looks like along the trail is this. You can see that those deciduous species are essentially gone. This is just below tree line, so these can be either young saplings kind of recruiting in at the edge of the trail here, where there's been a bit of a release of resources, and they can indeed be mature trees that are just very, very slow growing. So just below tree line in the subalpine elevation and latitude zone, we have evergreens, in this case red spruce. In other places in northern New England it'll be black spruce, it'll be balsam fir, hemlock, eastern hemlock, and so forth. Moving a little bit further up from the red spruce stand, there at the tree line, we can see visible color differentiation between the evergreen species and the broadleaf species, just trying to hang on in this subalpine zone. You can see a lot of patches of gray or exposed bedrock where the trees are just completely unable to maintain any sort of a footing. And continuing just slightly higher in elevation, we can see a couple of things here. So at the subalpine transition zone, which looks like this, even the trees have been replaced by what are called crumb holes, or trees that are the same species but much more negatively or adversely affected growth forms. So here in the background we have trees that are shorter than I am, about 5'10", just under 2 meters. And to the left we have a bunch of shrubby species that can be things like low bush blueberry up in the northeast. We've got patches of open rock, in this case granite, and it is a very difficult growing situation. Now we also have patches of snow on the ground. So again, by moving upwards in elevation, we've moved forwards effectively in time right into winter. So one effect of this in a subalpine zone is that we can see, running from bottom right corner to top left corner, we can actually see the trail from a great distance here. Instead of being covered by canopy, the canopy is about knee high or waist high here, and so that means human use features and human use impacts become much more prominent and even physically visible on the landscape. Heading up to the actual tree line, we get the very last glimpses of woody vegetation that can just barely hang on. So here to the left we have a shrub. Here to the right we have mossy bryophyte type species, just kind of basically generating and holding together tiny little clumps of soil in low spots and crevices where it's not scoured by wind and rain and ice, and also importantly our boot prints. Okay, so this is a difficult spot for anything to live in, and it's all based on elevation in this case. Moving all the way up to the summit, we now finally get to a place where there is no vegetation proper that can quite hang on. So this is for a couple of reasons. This is the hardest scoured by precipitation, so wind and rain are going to be extremely intense up here during winter storms. And also any soil that's generated by the low clinging crustose lichen that might be a millimeter thick in places. The waste products of those symbiotic colonies of cyanobacteria and fungi and algae and other microorganisms that combine to form crustose lichen kind of grows on the open rock faces, and the waste products that those communities give off actually physically digests the rock, like chemically. In the same way that a starfish externally digests its food, these symbiotic microorganism communities start to digest the rock, and those storms wash that sort of proto-soil and those soil nutrients released from the matrix of the granite downslope. Our boots kick and dislodge and mechanically transport that soil downslope. It collects in these thin valley soil lenses and supports what growth this northern forest can manage. So that is the combined effect of latitude, which is high here. This is far away from the equator, up towards Canada. Elevation, this is over 3,000 feet above sea level, so not the highest mountain of all, but even with only a few thousand feet of elevation change, we see a dramatic change in forest structure, age, species composition, and growth vigor, and the effect of topography. So when you kind of get back from this peak and look at the mountain as a whole, we can see here now that weather patterns are going to hit this and be forced up against this peak and this ridge line here and dump a heck of a lot more precip, because it has to do that. When a cloud gets pushed up, it gets colder and has to dump all of its precipitation. So there you go. That's how elevation latitude and topographic features combine to kind of drive the kind of forest that you're seeing.